Alright, so today for, what is today? October 28th, we have 2-2 and probably 2-3. A lot of you started 2-2 yesterday because we started the lesson. So reminder of why does this graph show a proportional relationship? We talked about this yesterday. You should have your notes out. And actually we wrote it into our notes. Lots of hands up. Isaiah, why does this show a proportional relationship? It goes through the origin and it's a straight line. So you want to make sure that in your notes down here, you have that a proportional graph will be a straight line that goes through the origin. So we talked really quickly, we're going to whiz through the first part of the lesson about why that is, and then checked 3 of them. So this will see if you were paying attention yesterday and or if you wrote this stuff down. I'm still out. Crystal? Question or answer? Answer. Is this proportional? Yes. Karina, what about this graph? No. What was our reason again? Doesn't go through the origin. And Bela, what about this graph? It's not a straight line. It has a kink in it. As soon as it changes direction, that ruins it. It is no longer proportional.
To make sure we're right?
Yeah, let me capture them. I'll check it.
Okay.
Or maybe I'll check it right now. Well done. All right, I think we're having a morning for smart. So go ahead and try the got it. Look at that and determine, is it a proportional relationship?
It's not bad.
Do you have it? You might not have it. No, you don't have it. So, Thomas, is this a proportional relationship?
No, because it does not pass through the origin.
But it's a straight line.
And it goes past the 4 and not the 0.
Yeah, the fact that it starts at the 4. So, pay attention. It has to have both straight line and origin. Some people like to make the argument of like, well, it has a straight line. Well, no, it's not proportional because it doesn't go through the origin.
I really like that when it's like asks us like an easy question, but they think it's like hard.
There is smart. All right, so move on to the back, and on the back of your notes, you'll see the next graph that looks like this. Now, this is actually an exponential graph. And why we call it an exponential is we'll use exponents when we're writing out the formula. So you don't need to worry about that right now. All you need to worry about is this a proportional relationship?
No.
No. Why?
No.
Okay, so it may go to the origin, but
It does go through the origin.
Up. Like it literally curves.
Yeah, it curves. So to be a straight, or to be a proportional relationship, it would have to go straight in a direction. Now this, some people say, well, this starts to look straight. It's still curving. It's a very small amount of curve. It'll actually end up looking almost like it's going straight up. But yeah, we can see, obviously, there is a curve down here. It is not proportional. So we want you to draw a proportional relationship, and you're going to have to label your axes. Now, depending on how tuned in your brain is this morning, you can make your life really easy here based on how you label your axes. So we want to show a proportional relationship, y equals 6x. We want to say, does this end up proportional? First step to graphing things, create a T-chart. So everyone should create a T-chart off to the right of your graph there, since on your paper you need to use the space right. Somebody asked about this yesterday, but they said, what about if x is 0? Because we were looking at a relationship where we had made the equation. So if I plug 0 into my x value here, every time we choose an x, it will plug in and it will spit out my y. So 6 times 0 would be 0. So then if I make x 1, 6 times 1,
6.
If I make x 2, 12. If I make x 3, 18. So then plot those points on your graph and determine whether it is or is not proportional. Now, again, first label your axes. I'll tell you the x-axis, you can just label 0, 1, 2, 3, 4, 5. That, like, the x-axis you can label by ones, but there's a really easy way you can label the y-axis to make graphing much easier here. How can we label the y-axis to make our graphing a lot easier?
So
Are you trying to tell me how to label it?
I know.
Cassidy, how should I label it?
You can do it by 5.
Ooh. We could, and then, but still, since I go to 6 and 12 and 18, I wouldn't land on perfect increments of 5. Bella?
You can just count by 6s.
We can label it by 6s. Now that kind of seems weird because it's not like an even number. It's not a nice, like 5 would do 5, 10, 15, 20. But when you are making your table, you choose whatever to label that you want. So I can make that line 6, that line 12, that line 18, this line 24, and this line 30. So then, when I plot my points, well, I had the point 0, 0, so I go ahead and put that down here. Because still, for my y-axis, this will be 0 at the very bottom. Then my point 1, 6 will fall right at that intersection. My point 2, 12 will fall right at that intersection. 3, 18 will fall right at that intersection. If I keep going up the table, I'd have 4 and 24, and 5 and 30. So then, to finish graphing, you have to connect all of your points. And then we normally draw an arrow at the end of it to say it keeps going. Is this proportional?
Yes.
Yes. It starts at the origin. And it's straight. So origin, straight line. That's what you're looking for. Questions, comments, concerns? So some of you have already taken off on the next one. Go ahead and try the got it then on your paper. The equation you now have is y equals 4x plus 1. So start by creating a t-chart. Choose your x values. I always suggest you start your x values at 0. I was nice and I gave you the graph. I don't have a graph up here, so I'm going to jump back to my notes page actually. So as we go and as we plug our x's in, whether you write it out or whether you just think it, I now am going to have 4 times my x value and then add 1 to that product. So 4 times 0, then add 1 to that. Well, 4 times 0 is 0, and then if I add 1, my y value is 1. For x equaling 1, I have 4 times 1, which gives me 4, but then I add 1, and yeah, my final answer is 5. 4 times 2 gives me 8, and then I add 1, so I get 9. Can anyone tell me if this is proportional, even without graphing it?
No, it's not.
No, you can't tell me?
I can't.
I got
I'm
it.
just joking. Emerald?
No.
Why?
Because it's not even.
What do you mean it's not even?
No.
2 to 9 doesn't
Wait, I know.
matter.
I got it.
You don't even need to graph this here.
There's no pattern.
There is a pattern actually. We're increasing by 4 every time. So there is a pattern. This is a linear relationship,
Oh, so straight.
but
0 and 0 equals 1.
you have to have a 0, 0 point to be proportional. We don't. We have a 0, 1 point. So when x is 0, y would be some value off the axis depending on how we label this y-axis. And that would be up to us, but all we know is that 0, 0 point does not exist. So this is not proportional, and you don't even have to graph it. because we see that we're missing that 0, 0 point, it can't be proportional. It doesn't have the origin there. Does that make sense?
Yes, sir.
You have to have the origin point. Now, don't get confused. That doesn't mean that this is bad or anything like that. This is a linear relationship. When I graph it, it would be a straight line. It'd be increasing by 4 every time. Like every time my x increases by 1. But without labeling my axes, that's just kind of like an approximation of what the graph would look like. Thomas?
What if it went through the origin and it just curved around? What would that be called?
It depends on what the graph looks like. There's lots of different names then. But because this goes in a straight line, we just call it linear.
What's one of the most used names?
Linear relationships. Because most things, like in the real world, have a linear relationship. Like when you go to buy gas, that's a proportional relationship. You buy 0 gallons, you pay $0. As soon as you buy 1 gallon, you pay $2.50. Let's say it's $2.50 a gallon. Buy 2 gallons, you pay $5. Buy 3 gallons, you pay $7.50. That's linear and proportional. Does that make sense? Okay. Cool. The cheetah problem. Don't be a cheetah. You don't have to laugh. It's okay. You can just like roll your eyes, but I'm still gonna keep making bad jokes.
I mean, I guess.
So we've got this cheetah.
That cheetah reminds you of wild crash.
Cheetahs run really fast. There's some cheetahs at the zoo. If you have not been to check out the zoo, I still have not been to the Africa exhibit. But
I love the
I
giraffes.
need to go. I know.
The giraffes are awesome.
So
far, one of them hasn't died.
bring it back. So it asks us, what does the point 190 represent? Well, again, all of our ordered pairs are xy. I'd like you to put xy above that 1,90. Just to remind you, the first value is always your x value. The second number in the ordered pair is always your y value. So we're looking at this point right there. So what does the 1 represent? And you can look at the label of your axis to determine that. Yeah, what was that, Divine? Time. How many minutes, seconds, hours? What's time measured in here? Well, what would this stand for? Seconds. So that tells me 1 is after 1 second. Well, what does the y represent?
90.
Bonger? Distance in feet. So we could say that for A, what does 190 represent? That after 1 second, and I kind of don't have much space here. After 1 second, the cheetah has ran 90 feet. Yeah.
Did you say that this is like the unit rate? Like
That point is because it's for 1 second. So yeah, very good identification there. So the unit rate of the cheetah would be 90 feet per second.
So in 2 seconds it would run 180 feet.
So in 2 seconds he'd run 180.
And it's proportional.
So look at B. What does 0, 0 represent? So Katie, can you tell us what the point 0, 0 really tells me? Yeah, if you've done something for 0 time, you really haven't done it. So he's been running for 0 seconds. He's ran 0 feet. So one way that you can put this is no time change, no distance. So then, Eli, what about after 3 seconds? You can use the graph or you can use your math.
3 seconds. Between 180 and no, that's just 270.
Just 270. So after 3 seconds, he's gone 270 feet because we find our 3 on the x-axis because that's where our seconds are at. And then we just follow it up until it hits my line. We trace that point over and we find out that's 270. Now this got slightly shifted up, your labeling, but those labels always coincide with the lines of the graph. Can anyone tell me what our equation would be here if we wanted to say y, the distance he has traveled, will be something times x? We could also say distance will be something times the time that he has traveled. Thomas?
Can I answer both?
Sure.
Y equals 90 times x, or D equals E times. Wait, R
The
times
equals
D.
is E. So this would be my
I meant to
rate.
say R,
Here's our
which
dirt
is
formula.
90.
Yeah. So distance equals rate times time, but my rate here, just what Bella had asked, is that 90 our unit rate? Yeah, 90 is your rate. So either of those formulas, those equations, would represent the cheetah's distance that he's ran based off the time. So now it asks me 900 feet. Well, if I wanted to set that up in this equation, we could say 900 feet is the distance. That will equal 90 times whatever the time is. Remember, our time is our x value. So what would the time have to be, Layla? 10 seconds. So our time here has to be 10 because 90 times 10 gives me 100. So t would equal 10 seconds. We cool? Does that make sense?
Yes.
Questions, comments, concerns about any of this?
Wait, so no, it's not about this necessarily.
Okay.
But like, so this is what our test is going to be about again.
Yes.
I thought you guys might like this because, so I don't necessarily agree with how Pearson orders everything, like the chapter orders. So based off what we've already done this year, I assumed this stuff would be kind of easier. So for this chapter, and then next chapter, chapter 3, we do more percent work. So I'm trying to get, your tests are almost done being graded. Tonight we have conferences, so I won't get home till after 9, so I may or may not get them done tonight. I guarantee I'll get them back to you by Friday. You will have them before the weekend. So then I figured you'll have time to review that stuff, revise that, and by the time we do percents again, you should be a pro. Like our second time around with percents, you should do really
Wait,
well.
so we do everything twice?
No, not everything. Percents, there's a lot that we do with percents, so we have a couple different chapters on it. Abby?
What do you think was the hardest unit that we've done?
So far, Unit 1, which we're gonna go back and do more. I'm trying to figure, now that we've done the proportional relationships, the rates and all that stuff will make more sense.
Which one is like the hardest?
I thought the percent.
It depends. It's all about your brain. So whether your brain is more of like an algebra brain or whether your brain's more of a geometry brain, because we'll get into like area and surface area and volume, and the thing with the three-dimensional shapes, that's kind of challenging if you don't kind of have a brain that can see shapes very well. But it all depends on your brain. So when we look here at the amount of nuts compared to the amount of dried fruits in our trail mix, this is sort of like if you want to make trail mix for the Phoenix Fair and you put in 1 cup of nuts, then how many cups of dried fruit do you use? Well, look at your graph. If we use 1 cup of nuts, how many cups of dried fruit would there be? 2. Right? Or sorry, pound. I was thinking cup. Pound is a lot though. So if we used 1 pound of nuts, then we would follow up from our 1 to the point where it meets our graph, follow it over, and it'd be 2 pounds of dried fruit. So then if I said 3 pounds of nuts, I followed up to my graph. So if we want to talk about the dried fruit, our y value, we want to make one of these equations. Y is what compared to x? We know this is proportional because it's a straight line through the origin. Zach, do you know what our multiple there would be? Yeah, because each of my y values is double my x value. So y will equal 2x, or you could say the fruit will equal 2 times the amount of nuts. You can always change the variables if you want. I know you don't have this on your paper. I ran out of space on the notes. I just wanted to talk about it.
So we're gonna get the 2.
I just want to make sure we.
Oh yeah.
Can I pass out the notes?
Sure, grab them. They're not on top, actually. I'll give them.
Can I do half of it?
Yeah, you do this after.
I'm so bad.
I'm gonna have to make it quicker.
And then the leftovers, just put on the laptop first. Okay. I'm actually going to stop the video, and I'll start a new one for 2-3, just so we don't have multiple things in the same video.